All right, so 10.1 is polar coordinates. Might need to get a different pen. Dang it. Yeah, one sec. Okay, so 10.1 is polar coordinates. So basically, we're going to transform our regular coordinates, which is Cartesian, the x and y coordinates, into r and theta. So let me give you a brief explanation before we start doing examples from your homework. So when graphing polar coordinates, r comma theta, first find theta on your unit circle, then move out from the center. And r distance. You guys read that? I don't know if I'm running too small.
I can read it.
Okay. All right, so let me show you what that means real quick. It's pretty straightforward. So they give you something like this. So it's given 2 comma pi over 4. Right, this is r theta, polar coordinate, right? All you need to do, so part, let's do a couple of them, I guess. This will be part A. So all you got to do is go to that angle, like we said. So pi of 4 we know is 45 degrees, right? So it's over here. Okay, so this is still x, y, but we're going to go out. Well, first let's swing that angle, right? This is, or sweep rather. That's theta equal to pi over 4. And we're going to go out 1, 2. So 2 units out. So this would be my graph here. Okay, does that make sense? You go to that angle and then you go out 2. If it was negative 2, well, you'd go to this angle, but then you'd go out this direction. Okay, let's go ahead and do one of those. Graph. Two comma pi over 4. Oh, sorry, this is the same one.
Is this going to be B or number example 2?
It's going to be part B. Equivalent point for, so I'm going to use the same point, but I want you to find an equivalent point. So still 2 comma pi over 4, because we know in the unit circle you can use many different angles to end up in the same place, right? So what is another coordinate that will get me to here? Polar coordinates. There's more than one answer. So one thing you could do is go to this side over here, and then go -2 to end up at this spot, right? I want to end up here. 2. So what you can do is pick an angle first, right? Let's pick 5 pi forward, get me to here, right? Now, if I choose a -2, that would get me to where I want to go. So if I end up at this side, we go -2 would be 1, 2. So this would be, these two would be equivalent to each other. Does that make sense what I'm trying to say? How we're still there, right? We're still here. It's just we got there using a different point. So first go here, 5 pi 4, and then go -2, which ends up to be here. Do you have any questions on number 1?
So it could be called like it's an inverse of the first point or something like that.
Well, I mean, we end up in the same place, but it is on the opposite side. It does feel like it's like some sort of inverse, right? But so the reason I chose this point is I was thinking, you know what? If I'm on the opposite side and go negative, that is the same as starting here and going out too. So always start with the angle and then go in this direction. Okay.
Okay.
Let's do another one. All right, number 2, plot the point 2 comma pi over 6. Right, so go to that location first. Pi over 6 is what, 30 degrees, right? That's about here. So you would go 1, 2. So your graph would be this here, this line. Let me see if I can show you prettier pictures. Maybe I'll wait till the next one. Because it is just the line currently. Okay. Let's take another example. Before we do the next one, you're gonna need some formulas actually. So x is equal to r cosine theta. Remember how we said x over r was cosine, so really it's just solving for x. But either way, here they are if you don't want to think about it. Y is equal to r sine. R squared is equal to x squared plus y squared. Tangent theta is equal to y over x. Assuming that x is not 0, right? Theta would be equal to pi over 2 if x is 0. All right. Let me find a simple question. The polar coordinate of a point is going to be this here. I'll pick 2 comma pi over 2. Find the Cartesian coordinate. In other words, find the x and y version, right? So let's write down everything we know first before we graph it, right? So we know r is 2, theta is pi over 2, and we can solve for x and y using these formulas, right? You can say, you know what, x is equal to r cosine theta, which means that x is 2 times cosine of pi over 2, which is going to be what? Right, cosine pi over 2. Whole thing is 0, right? So x is 0 in this case. Now, y, let's solve for y. 2 sine of pi over 2. That would be 2 times 1, which is 2. Okay, so the coordinate would be equivalent Cartesian coordinate is 0, 2. Now, if you graph this guy, you're going to be on the y-axis, right? And then you go out 2, which is the same as saying 0, 2. So see how you didn't really need it for this example, but I wanted you to see why they're the same. Right, if I go to pi over 2, which is right here, and go out 2, that's where I'm at. That's the same as the point 0, 2. Right? Does that make sense?
Yes.
So the conversions aren't too bad, but they're not usually going to be this pretty. I just want you to see with this first example that all you're doing is plugging in numbers. Usually you'll end up with square roots or something. Let's do a harder one. The polar coordinates. So it'll be the same question. Polar coordinate will be 11, comma 2 pi thirds. Find the, this someway is a different word, rectangular. Same thing as Cartesian coordinate. Just depends which math book you're reading of this point. All right. So write down what we know. R is 11. Theta is 2 pi thirds. So solve for x. Because Cartesian means, when they say Cartesian or rectangular, they want you to find the x and y version of r theta. That's all we're doing. So our cosine is our formula, which will be 11 cosine of 2 pi thirds. Y will be r sine theta, which is 11 sine of 2 pi thirds. Cosine of 2 pi thirds, that's going to be what? The negative half? Sine of 2 pi thirds will be square root 3 over 2. So the Cartesian or rectangular coordinate is simply negative 11 over 2, comma, 11 root 3 over 2. Right? Once you multiply that out. I did not multiply here. But you guys see that, right? Or no? Do you guys have any questions on number 4?
No, sir.
All right. Okay, then let's go the other direction. Let's go from x and y to r theta. Okay. The rectangular coordinates of a point are given as 7 comma 7 root 3. Find the polar coordinate for the one they gave us, right? Okay. So we have X. We have Y. We do not have R. Well, we do have a formula, right? We do know that x squared plus y squared is equal to r squared. So that would be 7 squared plus 7 root 3 squared equals r squared. Let's go ahead and do this over here because that looks messy. R would be equal to the square root of x squared plus this squared, which is going to be a 3. Okay, that would be, I don't know, like adding numbers. 4 times 449, right? Which would be 2 times 7. Is that right? Yeah, 14. Anyway, so we got R, and we got X and Y. So now we can, now all we need is theta, right? Once we have theta, we should be able to get the last piece. Okay, so the formula earlier said that tangent of theta is equal to y over x, right? So that would mean that theta is equal to tan inverse of y over x. So let's go back to that notes over here. I'm gonna make an extra formula here. Theta is equal to tan inverse of y over x. That's what I'm using. I forgot about that one. So that would be tangent inverse of y is this ugly number over this guy. So that would be tangent inverse of root 3, which is going to be pi thirds, I believe. Okay. So then put it all together, right? We got R, we got theta. So 7 comma 7 root 3 would be equal to 14 pi thirds. This is an x and y, and this is an r theta. So this is our answer here. So I had to do this, use this to find theta. Is there any questions on what we did there?
No, sir.
No, sir.
Not too bad then? Okay. All right, so the first, maybe the first half, the first few questions will be just like that. But then they'll switch to something like this. Example 6. The variables x and y represent rectangular coordinates. Write the equation using polar coordinates. All right, so This time we're not converting a point into either direction. We are converting an equation that's in x and y into an equation that is r theta. Okay, so here's what they're going to give us. 2x squared plus 2y squared is equal to 8. So the things we're going to need is stuff like x equals r cosine, y equals r sine, x squared plus y squared equals r squared. It's the main stuff that we need. Now, I see an x squared and a y squared there, right? So we can just factor that out and then divide it, right? So we'll divide it right here on both sides, leaving us with 4 on the right-hand side. So now, before we do anything, what does this look like to you? What type of graph is that?
A circle?
Yeah, it's going to be a circle, right? Circle of radius 2. So technically, you should know the answer that this is just r equal to 2, right? Circle with radius 2. But if you didn't see that, we have the formulas, right? We know that x squared plus y squared is equal to r squared, right? Using the formula. And if I solve for r, I would get 2, right? When you square root both sides. So what this is saying, basically, do you remember back when we had graphs like this? Let me take a little side step over here. When you graph something like this, you would have just a horizontal line, right? Just that, right? Just like this. So as x equal to 2, you would have a vertical line here. Does that, you guys remember?
Yes.
So for r equal to 2, it's the same concept as this, meaning when y is equal to a constant, x can be anything, but y will always be 2. Here, y can be anything, but x will always be 2. Over here, though, the radius is always 2 for all angles. So meaning, I'm going to go in a circle, right? Making my radius 2. So let me give you an actual graph this time. Okay. All right, so r equal to 2 is my circle, right? Because no matter what angle I choose, r is always 2 for all angles. That's how we form it. Just like we used to do y equal to 2. No matter what x is chosen, right? You can even see the x's right here. Y is always 2 for all x's. That's what creates the horizontal. I'm hoping that helps you remember. But also in Cartesian, right? In rectangular form, the same deal. Oops, that should be a 4. See how it's the same graph? So that's what we're doing. We're converting from x and y that we're used to this new thing called polar, r and theta. Okay. Is there any questions on example 6? This is the answer. I converted the circle equation into a polar circle equation. Yeah, theta can be anything, no matter what. So when you don't see a theta, you assume it's all real numbers, just like we did back in x and y days. All right, let's do a couple more, and that'll probably call it for the day. Okay. Convert to a polar equation. So this time giving you x squared equal to 13y. So we don't have a circle thing going on, so we're gonna have to use our formula and try to simplify the best we can. So let's go ahead and plug it in, right? X is our cosine, so plug it in for the x. Y is our sine, so let's go ahead and plug that in. So I'm gonna end up with r cosine theta squared equal to 13 r sine theta. So right here, use formulas, right? Now at this point, just simplify, see what happens. We square this side, we're gonna end up with r squared cosine squared theta equal to 13 r sine theta. At this point, you try your best to see if you can simplify it, but sometimes you can't, and this is the best it's gonna get. So I'm gonna just set it to 0 and call it a day. So this is my polar equation. And this was my rectangular. Is there any questions about this problem? So convert the following to a polar equation. Let's do one more. Try to do all the ones that I saw in your homework or similar problems. So you have an example. So this will be, let's see, 15xy equals 1. So just go ahead and plug in x and y as r cosine, r sine, and see what happens. It'll be 15 times r cosine theta times r sine theta equal to 1. Now let's go ahead and multiply that out. You'll have 15r squared cosine theta sine theta equal to 1. I don't see it getting much prettier, except, well, we could use an identity, I guess, right? I could multiply both sides by 2 and rearrange this so it's more obvious to you. Right, this guy right here, right? I multiply this by 2 and this by 2. So that make you guys see what I did there? So I can change this into sine 2 theta. So the best that I can do is to change it into this. But it's not much prettier. It's a little bit prettier, but divide by 2, I guess. But honestly, it's already, or it's been in polar form since this point here. After that, I'm just doing algebra to see if I can condense it or simplify. Usually, you should always check to see if something combines or if a sine squared plus cosine squared pops up, because then you can simplify that too. But sometimes there's not much to do. You'll see once in a while that there is, but this is the best I could do. I don't think this is wrong. This one's just prettier, I guess. I'm hoping your homework didn't give you problems with that. It shouldn't. But let me know if any weirdness happens, because both should be acceptable. Guys have any questions on converting points from Cartesian from rectangular to polar, or polar to rectangular, or converting equations back and forth?
So X always will be R cos theta, and Y will be R sine theta. That's
Yeah, so it's gonna be that way.
Always, okay.
Mm-hmm. Now, if you see x squared plus y squared, you can replace it with r squared. All right, guys. If you have no more questions, we'll stop here. If you have questions, please say and let me know. If not, you can head out for the evening.
Thank you.